So this is kind of like the final product. And now we need to talk about how I think the search is going to work and how what's failed before and what I learned last time. So again, remember, we want this to be a fast, mobile first, up-to-date, reliable, solid fallbacks, high uptime, affordable. So first off, we need to talk about what all this stuff means. So let's say that there is a folder with 30 files inside of it. Quick tip about Excalidraw. If you're looking to make a lot of duplicates, just copy the duplicates of the duplicates, and then these things grow super fast. So I have all of these files, right, in this folder, and within each of these files is some text. Okay, so each file is composed up of a lot of text, and with Obsidian searching, we're not going to just be looking for the exact keyword, because then we can just do that in Obsidian. The idea is that we want to, instead of searching lorem, we'd want to search forum or borum, and we would still want this note to appear. So what that involves us doing is creating this marvelous thing called vector embeddings. Basically, each of these files is an object to be embedded in this embedding, and then it gets turned into a list of numbers, this like 0.6, 0.3, 0.1 on the right side here. And these are vectors that are what we call have like a certain dimensionality. So you can have 1024 vectors, you could have 2048 vectors, you can have pretty much any amount of vectors. But these vectors can be compared to each other on multiple dimensions. So there's, again, the spell check, for example, where I said searching for the word forum is like equals like lorem, but it's not equal to tempor, right? So there is a relationship between all of these numbers that might exhibit like later on in the vector or in multiple areas of the vector. And we use this thing called cosine similarity to find the closest two together to return our semantic search. There's a lot of hand waving. There's a lot of stuff that I didn't talk about there too. But that's kind of the general point. In this space, we need to do a certain amount of tasks, right? So again, this is kind of like our overall kind of goal here is to get everything into these embeddings. And then once we have them in our embeddings, we want to store them in a database. So we need to store these vectors inside this database. And they all need to go in like this. But not only do they need to go in like that, but then we also have to store reference back to its original file, which is actually kind of a problem because in a regular file folder thing, there's not really IDs. Like you have file names, but file names can change, right? So let's say that, for example, you have a file called Boom Switch and you decide to name it Moom Switch, you know, because you were really interested in the Moom stuff that I was talking about earlier, and you were so fascinated by it. If you do that, you lose this link, in theory, between the vector that's storing it and the link itself. And that sucks balls. That was the part that actually held me up on this. The last time that I did this type of project, this actually is like my third attempt doing this thing. The first two attempts failed, not because of the search problem. The search problem is actually relatively solved. The problem was the indexing and storage problem. Like, where do I keep these things and where do I keep the reference to the original data to actually go and fetch the file that I'm looking for? And then how do I store things in terms of like sentences versus whole file embeddings and stuff like that. And then I've tried this 2-tier model, and we'll talk a little bit about these strategies as we go forward. But basically, this is a really hard problem, and there are a few players in the space that have came at it. So let's talk about those players. It's Pinecone. Let's call these vector storage players. So the first one is Pinecone, And the second one is this company called, it's not even really a company. I think it's run by a guy who runs a company though, Text AI. So I've had experiences with both. I've had pros and cons of both. The pros of Text AI. So let's say that we have like a pros column here. It's free. The maintainer is very active, uses FAISS. Those are the main benefits of Text AI. They do a lot of things that are shared too, so I won't really talk about what they do that's like shared because they both do them, right? The pros of Pinecone is that scales really well, secure by default, question mark. I don't know if this is really the case, but I think that that's where kind of like the main pros that come to mind are. The cons are it's crazy expensive, and I would say it's kind of hard to build for. This also has a SQL plugin. The cons of Text AI are that it is self-hosted, which is a pro and a con depending on how much you're planning on running this. I would say that actually, at least with the experience that I've had using both of these tools, it was easier to code on Text AI than it was with Pinecone. And I like Pinecone. I think that like I've talked to a few of their guys and they have a really good product, but I think that in the vector storage space thing, I just liked using Text AI more. It made more sense, I guess. Yeah, so they both have trade-offs, right? Like they're not neither of them are perfect. And it really just depends on the use case that you're building towards. I think for what I'm trying to do with Obsidian, I need to be thinking about what's going to be the best for this particular use case, right? Like I don't need if I were running a company that had a lot of money and could just spend it, I would probably be using Pinecone. But the whole idea is that I don't want to pay $50 a month to search my Markdown file and then still end up Google searching, right? Like that's kind of ridiculous. I should be able to find a way to do it for free and be maybe a bit more creative about it. There is a world where I just host these vectors locally. The problem is that they take up a ton of space. And actually, now that I'm thinking about it, this is my fourth time working on this. That's crazy. I still don't have a great solution. Like it's that hard of a problem. Now let's talk a little bit about indexing a file, what indexing a file looks like. So when you have a file like this, you need to make a few decisions about how you're going to index this file. So you can do what's called sentence level embeddings. So you can just take a single sentence and embed it. So this is going to be a sentence level embedding. Then we have our document level embedding, which highlights the entire document. Both of these also have trade-offs. This problem is complex enough that the whole thing is about basically managing trade-offs. Like there isn't a right or wrong answer because it's so dependent on so many different factors about how frequently your data is being uploaded, how frequently it changes, how it's shaped, how many repetitions there are, how many dimensions you want to test against. There's just so many things to consider with this problem, which is probably why I've tried to solve it 4 times and failed each time. And it doesn't seem like it should be this difficult. Like I've come across a number of different ways of doing this that I'm like, oh, that's kind of clever, where you can kind of use tagging in the back end. So instead of searching directly against a word, so instead of searching like, Ludwig. So like when I search the word Ludwig, I probably mean the streamer, right? I'm talking about Ludwig the streamer. So like what this would do in the back end is it would add tags to Ludwig. So it'd be like streamer, Atrioc, Beauty Cinderella, ... right? So basically what this does is that when you're actually hitting this keyword, it would go and find the tags that closely match that, which could be multiple things, and then it would actually search against these words manually too. So it would search streamer, it would search Atrioc, it would search Cutie Cinderella in your database whenever you search Ludwig. We don't want that shit. We actually want similarity embedding, because that this tags thing in theory is baked in to this, right? Because what we did here was that we said that Ludwig is a streamer, he knows Atrioc, and he knows Cutie Cinderella. So that means that these things are highly semantically linked, is what we call it, right? So when something is semantically linked, it's closer in vector space to something else than like a penguin or something like that. So that should already be, in theory, in our data, our vectors. So we shouldn't need to worry about that. What we do need to worry about is how data is going into our thing. So basically for our embeddings have a few hard stops, right? So let's say that we have our embedding no fly list. So our embeddings no fly list kind of looks like a few rules, basically. It's the 10 commandments from Hamilton. What's that called? The 10 commandments. The embeddings no fly list basically consists of tokens must not exceed token threshold. So that's the first thing, is that tokens can't be bigger than the token threshold. And that brings with it a whole slew of problems, because like if you wanted to do document level embedding and your document just happens to be bigger than the token limit, then it just won't work, right? Another problem is like, what happens if your document level embedding is just filled with just random bullshit, right? So there's a lot of cases where you'll have a document level embedding. So you'll have your regular text here, right? But the problem is that most of this text, so like it'll be like laborum, but then it'll be a bunch of hot garbage. So it'll be like a bunch of like random keywords or like headings or like, freaking, bold keywords or like HTML tags, just a bunch of garbage, right? And if you are looking for the word laborum and you have to run through this whole document level embedding for just that word, you end up almost shooting yourself in the foot because you're looking for you've embedded a whole document that's effectively trash, right? And it's not trash, it's just formatted trash. And there are a few tools out there that allow you to deal with this problem. Basically, what we would want to do is we would want to remove the Markdown formatting from our string. And there are a few libraries that do that. So here's one, for example, called literally remove Markdown. Oh, wow. I almost just input 700 screenshots into this Obsidian vault. That would have been pretty bad. So there's libraries like this remove Markdown library that like goes through and strips Markdown from text. So that's something that we're interested in. Again, the problem is though, right? There's all these trade-offs, right? So even if you remove the Markdown, you might be removing emphasis, which actually is important for the document level embedding. So like if there's like emphasis on a word where you were really trying to say like, oh, this is really important, if that's gone because it's now just treating it as all flat text, or a heading, for example, right? You'll have the objective like splitting things into headings and kind of just searching headings instead, because headings usually encapsulate what's their children, which now that I think about it, maybe that's the move.